maybe what you have seen in the schedule and what I am going to present is little different, but I am going to talk on big data analytics, looking at fifth V of big data. What is I think you already know about 5 Vs. I think more. So can anybody guess what is fifth V of big data? Yeah, value. So what I am going to talk here is how to bring value to the big data. Still, I have not been working in this area for a long time, but I have been working in the area of artificial intelligence, machine learning for 6 to 7 years. So I will bring that perspective here. I think you already know about what is big data and all those things, so I need not worry about these things. So these 5 V's, okay, volume, velocity, variety, and veracity, you already know about these things. How to bring value to the data, what we have, that I am going to talk about. That is the fifth dimension of big data. So we have seen so many presentations there. Okay, wow, how within a second, 60 seconds, how much amount of data can be generated and all those presentations. Now, so we have data. Now what we can do with all that data, that is the most important thing. Actually, without this, what you are talking about big data, actually no, many companies doesn't bother about without this content, means value. If there is no value in that data, many companies are not bothered about that data. Actually, I was talking to somebody in the software 2 months back. He was saying how big data came up and now nobody is talking about big data, it's already gone. So, okay, so what can we do with the data? So we want to exploit the data to use it for the maximum extent. So how we can convert the data into information, the knowledge, insight, and success. This is what most important point for companies. How to bring success to their company. So, and recently the business needs are changing. Earlier we used to look at by using the data, we used to look at what happened and why it happened. We are in that perspective. Now things are changing. What is happening in real-time analytics and why is it happening? People want to know. Even some companies are looking at what is likely to happen. So predictive analytics and what should I do about it? If something is going to happen, I already know how I can change that. Or that is prescriptive analytics. So those things are very important for companies now. So I think this is also somebody presented, so I am not going into this slide. So these are the challenges comes from big data. Cost efficiently processing the growing volume. How do you manage the growing volume of the data? Responding to the data with increasing velocity, streaming data, and how do you collectively analyze the variety of the data, like structured, unstructured, and semi-structured data. Another thing is how do you tackle with uncertainty in the data. As a machine learning professor, I talk about, I am not talking about veracity, I am talking about uncertainty in the data. So I think this is also people have talked about why big data is not new. Big data is not only about massive data volume, and big data means how do people think, but that is not only Hadoop. Big data means unstructured data, but it can be used for all varieties of the data. So how important this big data is? So we have the data. So without big data analytics, companies are blind and deaf, wandering out onto the web like deer on a freeway. So this is one comment given by expert. And data is the oil of the 21st century, and big data analytics is the combustion engine. So how big data analytics bring value to the companies is very, very important concept you have to look at. So till now what we are doing is, until unless the big data technology comes into picture, we are doing this. So we can't see the big overview picture of the data, so we are looking at the local solutions and we think something else. Until unless we do machine learning and predictive analytics and whole data available. So data, not a byte to byte. So, and why we are talking about big data analytics now? So data-driven decision making is the mainstream thinking. This is what very important for the companies. Now everything is data-driven, and IDC forecasts next essential capability of big data foundation is the intelligent economy, and the economic benefit or value of the insights can far exceeds costs of acquiring and storing the data. This is what important. So this is why we are looking at big data analytics now. And also we have a big data platform where they can give us reliable, scalable and distributed storage and parallel processing. Okay, this also so key enablers of the appearance and growth of the big data is nothing but one of the increase in storage capabilities. Because of the cloud computing environment, we can deal with huge amounts of data now, and increasing the processing power. Even simple desktops, we can form a cluster and we can do very complex operations. Availability of the data, so we already know about so much amount of availability of the data, and the availability of different tools and technologies, something like big data technologies called Hadoop, big data platform tools, Hadoop, and other machine learning technologies like R, Mahout and SAS, and there are many other predictive analytics tools are available. So this, okay, I may not go deep into this, but just I want to, these are the main big data technologies. Why do you need Hadoop? For low cost, reliable, scale out architecture, distributed computing, and parallel tasking, and moving program to the data than moving data. And NoSQL databases, not only relational databases, we can do variety of databases, deal with variety of databases. These are the different databases and technologies exist. And for predictive analytics, you have R, Mahout, we have the RapidMiner, NIME. These are the freely available tools. SAS and other things are commercial tools. And for data visualization, jQuery Visualize, these are the open source tools, R and JP Graph and Ruby GraphViz. And there is another tool, it's open source and also commercial version is available, Tableau. So I want to stress most on this data analytics life cycle. So what actually, suppose if we want to extract useful information from the data, what are the steps we need to follow? So first, identification and formulation of the problem. How do you formulate the problem is very, very important. You have the data, but what I am going to do with data? How I can use that data? So for that you have to formulate some kind of problem, and then you can use the techniques available. Another one is data acquisition and management. Another step is data preparation and selection, which is very, very important aspect of data analytics. Then building and validating the models. Then visualization and communication, communicating the insights, and deploying the models and operationalize. So these are the data analytics life cycle. So suppose, how do you formulate the problems? I have few examples. For example, a rule, onions, potatoes implies burger found in the sales data. So this is generally used in retail market analysis. So this can be posed as association rule mining problem or market basket analysis problem, and you can solve this problem by using the techniques available. Healthcare analytics. Patient can be classified as high risk and low risk patient on the basis of disease pattern. So you can go into healthcare data and you can classify him into high risk and low risk. This can be posed as the classification problem. I am fitting the problem into machine learning concept. Financial analytics, predicting the stock market price as well as predict stock market trend. You can pose this as a regression problem. So once you have the data in different domains, you have to formulate the problem. You have to think about that first. Then data pre-processing. This is the most complex task of analyzing the data, because we see incomplete data, lacking of attribute values, lacking of certain attributes of interest itself, and containing only aggregation of the data. And one more thing is noise in the data and outliers in the data, and inconsistency. We are containing discrepancies in the codes and names. These are the characteristics of the general data available over there. And what is important is good data preparation is key to producing valid and reliable models. Once you want to apply data mining and machine learning techniques, how you can prepare the data is very, very important aspect you have to look at. And okay, in either machine learning or data mining, how we are going to use that problems in terms of either attributes. Suppose there is an object, how I can describe the object in terms of attributes in data mining, features we call in machine learning, patterns in pattern recognition. So you can call it any name, both all are same, but they actually those attribute values can be either discrete or continuous attributes. I hope you all know about these things. There are different types of attributes also, numerical and categorical attributes, and outliers, observation values inconsistent with the data set value. Somewhere the order of feature value is hugely different from the whatever existing data values. So how to deal with these outliers, and how to deal with the discrete and continuous attributes, how to deal with numerical and categorical data, you have to understand carefully. So these are the steps in pre-processing. Generally we do sampling. Instead of using entire population of the data, we can take samples of the data that should be represent entire data set, and then you can work on the machine learning. You can use machine learning techniques. Another one is outlier and anomaly detection. Another one is dimensionality reduction, where you have now thousands of features. Somebody was talking about 2000 features they have given. So, but making reliable models when you have large number of features is very, very difficult, because once dimension increases, you need huge amount of training data requires to apply either data mining or machine learning algorithms. So how I can reduce the dimensionality without losing the information? Of course, there is some loss in information, but I want to minimize the loss. Data normalization and standardization, this is also very important aspect when you are applying machine learning techniques. Generally, when you are using data mining or machine learning techniques, it thinks about actually data is normally distributed, in general assumption, but it is not correct in the real world. So how do you normalize the data and standardize the data, where standardization is nothing but bringing mean 0 and standard deviation 1. This is true for normal distribution, but not for other distributions. Another one is nominal to numeric conversion. Sometimes, suppose if you want to apply some machine learning techniques, they are not directly applicable for categorical attributes, so nominal attributes, so you have to convert them into numeric. So how are you going to do that? And sometimes you want to do aggregation and also generalization, and you want to, we also has to tackle about missing values. How do I fill the missing values? There are some techniques to fill the missing values. Yeah. Once I prepare the data, okay, data acquisition is not a big task because we have so many tools to acquire the data. Then I prepare the data and how I can use the building, how I can build the models. I can use various data mining and machine learning techniques to model the data and extract, discover the patterns which are hidden in the data sets, large data sets, which is called data mining. And machine learning is actually the core algorithms of data mining techniques are machine learning. Generally how a human will learn, that I want to mimic in the computer. So generally how you identify your another fellow. So you have what kind of processing is happening in your brain. Suppose you want to identify some object. How are you recognizing that object? What is that complex task happening in your brain, which cannot be easily explained. It's not easily explained. So how we can bring that as an algorithmic perspective and how we can learn such kind of tasks. Even speech recognition, NLP, language processing. Suppose if I ask an accountant, there is some person, and I ask somebody how he works, so he replies, oh, he is like computer. But actually, that means he is working like computer. How do you bring semantics and other things into picture here when you are working with data? So you, and okay, the goal of machine learning is to build computer systems that can adapt and learn from their experience. This is what generally we do when we go. Suppose I am from Andhra Pradesh. Initially, when I come here, I could not adapt to this food. So somehow now I am adapted. So my biological system is adapted to this environment and food. I used to sweat a lot in the beginning. Now I am not much sweating. I am seeing. So this biological adaptation. And how do you learn the concept? Suppose a baby want to identify cat. So how does she learn? She identify the cat. Generally, I am professor, so I will ask questions. So how do a baby identifies cat? So you show her 10 times. Okay, this is cat, this is cat, this is cat. So suddenly she may identify cat, but you are showing red cat, and sometimes you are showing some other cat or different colors cat. She may not recognize that time, or after seeing several times, she will recognize. Okay, this is also a cat. So you are going to present these examples in terms of examples to the machine learning techniques, and it tries to learn from the examples. So why machine learning is very important task? Some tasks cannot be defined well except by examples. I already told you, how do I recognize my friend? I don't know. Seriously, I don't know. But I am recognizing. Even after seeing 5 years, I can recognize. But what is the model I have in my brain? I don't know. And relationships and correlations can be hidden within large amounts of the data, which is you cannot directly observe. Suppose if association rule mining, suppose somebody is buying a potato and something I already told you. So which is you cannot see if there are a large amount of data, you cannot directly observe. So you need machine learning techniques there. And humans are unable to explain their expertise. Suppose speech recognition, how you recognize speech, which I don't know. Of course, there are, we recognize speech in terms of frequencies, but that we are applying same thing we are using for speech recognition, but by humans. In medical diagnostics, I cannot represent with small number of parameters, and environment, when environments change over time, when new knowledge about tasks is constantly being discovered by humans, how I can incorporate that knowledge constantly. So I have to use machine learning techniques there. But we have seen several advantages, but there are many other issues with machine learning. What algorithms are available for learning a concept, and how well do they perform, it is not easily known. How much training data is sufficient to learn a concept with high confidence? Generally, I used to ask, suppose I want to recognize speech, Tamil speech recognition, I am actually speech recognition expert. How many samples, how many people I have to record to recognize speaker independent, to do speaker independent speech recognition, which I don't know easily. Do I have to record 1,000 speakers or 10,000 speakers, which I cannot easily explain. When is it useful to use prior knowledge? I already have knowledge about the data. How I can put that prior knowledge into the machine learning techniques is very typical, not very trivial. And are some training examples more useful than others? This is also you have to look at. And what are the best tasks for system to learn? Some task computer cannot learn easily. So how do I identify what are the best tasks system computer can do? And generally we talk about machine translation, which humans does very easily. So, but actually India, 30 years people have been trying machine learning. The crores of projects have been poured into machine learning by government of India. Still, there is 16% accuracy in machine translation. So it's a very complex task. So people are talking about human-aided machine translation, where I can bring into human when the complexity is more. Only human can do very well in that context. So what is the best way for a system to represent its knowledge? This is also very not easily known. How do I represent knowledge, my world knowledge into the system? Suppose if I ask a snake killed the rat and swallowed it. It's a valid thing. But a rat killed the snake and swallowed it, which is not meaningful to you, but how I can tell the system? This is not a valid thing. It's not easy. How do I represent that knowledge? How can we optimize the accuracy on future data points? I have so large data points, but how I can accuracy I can optimize for the future data points, which is very difficult task. And some learning problems computationally tractable. So some are not tractable. Suppose I was doing on natural language parsing, where theoretically it used to take 1,000 years to give a parse for one sentence. Best parse for one sentence it needs. Okay, we have some other assumptions and techniques and we can get the best parse, but theoretically I need 1,000 years for one single sentence. And how can we formulate application problems as machine learning paradigms? This is very important. Okay, these are the different techniques available. Generally, when you go to even SAS and SPSS and wherever you go, you see these different techniques: decision trees, association rule mining, linear and logistic regression, artificial neural networks, k-nearest neighbor classification, and most of you might have been used KNN and other for sentiment analysis. I think I have seen Analytics, they were using this for sentiment analysis, and ensemble learning, Bayesian belief networks. There are many different techniques available which can bring the hidden patterns in the data and solve the problems of analytics. So these are the tasks which can be performed. So you have to fit the task into one of the, fit the problems into one of the tasks. Either I can do classification, or I can do association rules, or I can do clustering, regression, which is nothing but prediction and forecasting, and sequential pattern mining, deviation detection. Okay, of course, data visualization is also one of the important concepts. So, okay, if I classify my machine learning techniques, what are available? So we have certain tasks. We can use different ML techniques for different tasks. Most of them are not applied for all the tasks. Only neural networks can be applied for any of the learning task in machine learning paradigm. Except that you don't have any other technology which can be applied, which can learn all other tasks in machine learning. So, okay, I think I'll. So these are the some use cases. Suppose car insurance. Can we find pattern for the unprofitable policies? Suppose when you do car insurance, they will tell lots of things. But when you go and apply for refund, then they will say, okay, this is not applicable. For plastic, I will give you only 50. For this something, I will give 25. So there are many hidden issues are there. Can we find such kind of patterns for the unprofitable policies? Even in healthcare analytics, and even many of you are talking about sentiment analysis and opinion mining, where generally people are looking at some CentiWordNet and other things, classify. Suppose if I see good and if I see very good, I will do something. Okay, I will give some value. But generally that is not true. When I say the battery life is long, long is positive. But when I say it takes long time to focus, but there is negative. So you have to use natural language processing techniques to actually do good sentiment analysis. Even we were doing product reviews, sentiment and product reviews also. And recommendation systems, these are very coming up for customization is one of the more attractive features in e-commerce, where creating a different product for every user suited to his and her tastes. So recommendation systems are coming up where you can use many machine learning techniques. Of course, I was talking about this, what you can do with machine learning techniques, classification of spam and not spam, and predicting stock market prices and classification, weather prediction, and there are many other places where you can use machine learning. Speaker verification, credit scoring, fraud detection. Of course, many of them actually need big data analytics also for fraud detection and other things, and quality of service, stock market forecasting. We can do handwritten character recognition, spam email detection, and all those things. Those are all machine learning applications. There is another aspect when you are applying machine learning technique. I think I am already out of time. I will just take 2 slides. When you are evaluating, okay, I have built the model. Now, how do I evaluate the model? Is very, very important. So you should use a training set, validation set, and test set. You have to divide your entire data set into these 3. Generally, people say I use. So when they are doing speech recognition, I have tested for my own voice and I am getting 90% speech recognition accuracy, which is not valid. So you have to categorize your data into these 3 sets, and then you have to apply machine learning techniques. And evaluation methods, other evaluation things are you have to have holdout data and stratified sampling, repeated holdout. You can do cross validation and bootstrap sampling. These are all different techniques available for evaluating your models. I think with that I will stop. If you want, I think use cases can be presented by many other people, so I will stop here. And thank you very much.